Got a couple of examples where we've got angles to find, and in diagrams where it's not just triangles but there's other things going on, and we're going to combine some of the angle facts that we already know. So this left hand diagram, we've got what looks like a triangle, except that two of the sides have going to be extended out. So there's an angle on the outside of the triangle as well as on the inside. So it's usually a bit of a kind of one step at a time when you're trying to solve these problems. In other words, decide what you can work out, and then that step might then lead to finding the desired angle. So for instance here, we want to work out A and B. It's quite straightforward to work out the third angle inside the triangle because we know that two of them add up to 47 add 71. 47 add 71 gives us 118 degrees. We know that all three angles add up to 180 degrees. So 180, subtract 118, is going to give us, what's that, 62 degrees. So we can go ahead, I'm going to write these other ones in I think in green. So we've got 62 degrees in here. Now, in order to get to the outside of the triangle, we've got a couple of ways we can do it, and the main one is to just focus on the fact that we've kind of got this. Let's look at this section here. We've got this diagram here, just in green, is something that you'll probably come across. It's just a straight line or a straight angle, and we know that if we had a diagram like this on its own, and I said to you, okay, I know that one of the angles, say, is at 40 degrees. What's the other one? Well, we know that the whole angle is 180, so the other one would be 140. So what we need to do is just isolate that junction in the diagram to say that if one angle is 71, well, what's the missing one? Well, A, therefore, is going to be 180 minus 71. So A is equal to 180 subtract 71, which works out as 109 degrees. Okay, it's 109 degrees. For B, it works exactly the same way. You can see we've got a junction here. So we forget about the triangle now, and we just say, oh look, there's a straight angle, 62 and B. 62 and something add up to 180, which means that we're looking for B is going to be 180. Subtract 62 degrees, and that works out as what, 118 degrees. Okay, so that's how we can do it. There's another interesting piece of geometry which we can go over at another point, but where you've got what we call an exterior angle, where one side extends out to make an angle like at A, the answer is also 109 is also the sum of the other two angles in the triangle that don't make that point, which is where 71 is. So if you add 47 and 62, you get 109. The angle at B here is going to be the sum of 71 and 47. So you can do it that way, but it's as easy just to look at the wee junction there. Let's look at the other diagram. So we've got an outside triangle, we've got a line in the middle that makes two smaller triangles. What's going on here? We're trying to find C and D. The important thing to kind of note here is that there's also a couple of extra lines in it, and that's these two lines that say these two lines are the same size. In other words, this triangle here at the bottom is an equilateral. No, it's not. It's an isosceles triangle. Okay, this triangle here is isosceles, which means that special properties come into play. Two of the angles are equal, but which two? Okay, is 62 one of the pair of angles, or is it the odd one out? Well, remember that the odd angle out is the angle that makes that join the two equal sides. So there's the two equal sides, so this angle is the odd one out, which means that the other angle, if I just get my pen, this is the other 62 degrees. Okay, which means that 62 and 62 is 124, so that means that's that's 124, and if we take 180 and jump the gun here, 180 minus 24, what's left? 56 degrees. So that's 56 degrees in there. So yeah, nearly I knew that it couldn't be because of the size of it. So it's always good to check, is that the right answer? 56 degrees. Okay, so we managed to work out two angles because this is an isosceles triangle. Now, what can we do beyond that? Well, if you notice up at angle C, well, yet again, we've got an angle, a straight angle here. Look at that there. We've got a straight line and a line that divides it into two. So that tells us that C and also 62 add up to 180. So C is 180, subtract 62 degrees, which is 108 degrees. No, it's not. It's 118. That's okay. 118 degrees, that's at C. So if that's 100, I write that in, 118, we know that's 36, and there's D. Well, there's another triangle. We don't know. It's not isosceles, but it doesn't matter because we know that 118 and 36 adds up to 154, and we know that all three angles add up to 180, which means that D is 180, subtract 154, and that's going to be 26 degrees. Okay, so that's how we can work things out. We need to combine our knowledge of angles in triangles, but also things like angles in a straight line, angles that make a right angle, X shape or vertically opposite angles. So use some of these facts, see if you can do some of these diagram problems just like that. Okay.